Hello everybody, this is Dr. Nurbadsha from University of Engineering Technology, Peshawar. I welcome you all to my channel. In today's lecture, I'll be talking about Laplace transforms of convolution of functions and if you have Dirac delta function, which are obviously used in impulsive phenomena. Okay, so first we define what is convolution. So convolution of two functions f of t and g of t, which is denoted by f steric g and is defined as, so f steric g, that is obviously an integral of f of tau gt minus tau. You see that g function जो है इसको हमने यहाँ से ट्रांसलेशन ऐसी करनी है, ठीक है. So g function is translated about t and tau is known as a dummy variable. Okay, so integrating this quantity, that is called convolution of two functions f and g. For example, if we have one function that is a constant function 1, whereas the other function is t, so its convolution can be defined as, you see, 1 will be written as it is what we have, okay, and whereas t, that's the second function, so we'll be replacing t with t minus tau. Okay, and then we integrate this with respect to tau. So you see, integral of t with respect to tau, that will be t into tau, and tau square by 2 is the integral of tau. So you see, after simplification, we'll be getting what, that is t square by 2. The convolution of 1 and t, that would be t square by 2. Okay, it plays very important role in Laplace transform as well. So we have a convolution theorem which is used for finding Laplace of Laplace transform of two functions. एक अगर f है और दूसरा g है, और उनकी convolution के अगर हम Laplace transform find करना चाहते हैं, ज़हन में रख लें, there is no rule for Laplace. अगर f और g multiply हो रहे हैं, तो we don't have a rule like Laplace of f and Laplace of g. Okay, उसमें हमारे पास रूल है कि Laplace f plus या minus g हो, so we could write that as Laplace of f plus minus Laplace of g. So this is f and this is g. This is known as additive law. लेकिन मल्टीप्लिकेशन में ऐसा नहीं होता. हाँ, कन्वोल्यूशन में ऐसा होता है कि अगर आपके पास f और g दो फंक्शन है, उनके हम कन्वोल्यूशन ले रहे हैं और फिर उनका लेप्लास फाइंड करते हैं, तो दे आर सेम एज कि पहले आप कन्वोल्यूशन फाइंड करें फिर लेप्लास ले लें, या दोनों के अलग अलग लेप्लास ले लें और फिर उनको मल्टीप्लाई करें. ठीक है, ये पॉसिबल है कन्वोल्यूशन में फॉर लेप्लास ट्रांसफॉर्म, लेकिन वैसे मल्टीप्लिकेशन में ये रूल पॉसिबल नहीं है. ओके, जिसका obviously in most of the cases बड़ा useful role होता है when we find Laplace inverse. ठीक है, so let's suppose if you want to find Laplace transform of e power t steric e power sine t, so what would you do? You would find Laplace transform of e power t, which is 1 over s minus 1, Laplace transform of sine t, which is 1 over s square plus 1, you know that. Then by convolution theorem, Laplace transform of their convolution will be simply the product of their Laplace transforms. So 1 over s minus 1 into s square plus 1 will be the Laplace transform of e power t steric sine t. Okay, similarly, if we want to find inverse of a product of two functions, Laplace transform अगर इसके हम find करना चाहते हैं, तो you can just go for the convolution of both functions after finding their Laplace inverses individually. So you see that Laplace inverse of f of s into g of s. So what would you do? You would find Laplace inverse of f of s, and you would find Laplace inverse of g of s, right? And then as a whole, Laplace inverse will be the convolution of this one and this one. So we have f static g, and it's obviously very useful in finding Laplace inverse for different हार्ड फंक्शन, जहाँ पे हम या तो फिर पार्शियल फ्रैक्शन यूज़ करते हैं या कोई डिफरेंट टेक्निक को हम यूज़ करते हैं. ओके, For example, if you want to find Laplace inverse of 1 over s square plus k square whole square, so what do? We could simply write this as 1 over s square plus k square and 1 over s square plus k square. इसको हमने split कर दिया and we wrote that as 1 over s square plus k square into 1 over s square plus k square. तो ये हमारे पास बन जाएगा f of s और ये हमारे पास बन जाएगा g of s. अब इसका भी हम Laplace inverse आसानी से फाइंड कर सकते हैं. That will be 1 over k into sin kt. इसका भी हम फाइंड कर सकते हैं, सेम फंक्शन है, सो इट विल बी 1 over k एंड देन अगेन sin kt. एज ए होल अगर हम उसका फाइंड करेंगे तो इतना आसान नहीं होता डायरेक्टली. ऑब्वियसली देयर आर मेनी मेथड्स टू डू दैट. पार्शियल फ्रैक्शन से कर सकते हैं, इसको हम डेरिवेटिव के रूल से कर सकते हैं, ठीक है. तो लेकिन यहाँ पर इसको हम कन्वोल्यूशन से भी कर सकते हैं. ओके, सो we'll be having now, this is basically same as Laplace inverse of the first one, steric Laplace inverse of the second one. The first one will give you 1 over k sin kt and the other one will give you 1 over k sin kt. This might be written as 1 over k square sin kt steric sin kt. अब ये इन दोनों का convolution है. So by using convolution definition, how do we do 1 over k square? And then from 0 to t sin k tau sin kt minus tau by using Laplace by using definition of convolution of two functions. Okay. अच्छा, अब इसके बाद अगर आप देखें तो यहाँ पर ये जो फंक्शन है इंटीग्रेशन फाइंड करने के लिए यहाँ पे वी हैव टू इंट्रोड्यूस नाउ ट्रिग्नोमेट्री. यहाँ पे हमें 2 चाहिए होता है, ठीक है. तो यहाँ पे भी 2 आ जाएगा. और फिर हमारे पास रूल ये है कि if you have 2 sin theta and you have sin alpha, अगर ये दोनों सेम हो गए पर तो अलग चीज़ बन जाती है. तो दिस इज़ बेसिकली इक्वल टू cos alpha theta minus alpha minus cos theta plus alpha. Now using this rule, यहाँ पे हमारे पास alpha की जगह क्या है, kt है. This is alpha theta in fact, that is kt k tau in fact, whereas यहाँ पे जो alpha है या theta है, जो भी आप कहते हैं उसको, that is equal to kt minus k tau. तो जब यहाँ पे पुटिंग आप करेंगे, so you'll be getting what, cos k2 tau minus t and cos kt. Okay, and then we could simple integrate now. The first one will be cos sin k2 tau minus t divided by 2k. The other one is cos kt, so it will be simply tau cos kt. We are integrating with respect to tau, keeping in mind, so cos kt will be considered as constant. And after simplification, we get what, 1 over 2k cube sin kt minus kt cos kt. Right? I hope you know how to integrate this one. So Laplace inverse of 1 over s square plus k square whole square is 1 over 2k cube sin kt minus kt cos kt. So you see that in Laplace inverse it is playing a very important role. ओके, नेक्स्ट वेल नोन फंक्शन जो कि काफ़ी ज़्यादा यूज़ होता है इंजीनियरिंग में, जहाँ पे भी हमारे पास इम्पल्सिव फिनोमेनाज होते हैं वहाँ पे डिराक डेल्टा का रोल आ जाता है. इसको हम यूनिट इम्पल्स भी कहते हैं. तो द डिराक डेल्टा फंक्शन इज़ डिफाइंड इज इट्स वैल्यू इज़ इन्फिनिटी व्हेन t इज़ इक्वल टू एट द सोर्स पोजिशन और एट t इक्वल टू a and it will be 0 elsewhere. It must be noted from the distributional calculus that integral from 0 to infinity delta t minus a dt, that is always equal to 1. Okay, and Laplace transform of Dirac delta function is what, that is simply e power minus as. You will be seeing this type of notation in differential equation जो कि हम next video इस पे आ रही है, ठीक है. इसका वहाँ पे यूज़ होता है जो कि यूजुअली सोर्स टर्म इसका इम्पल्सिव हो, यूनिट इम्पल्सिव हो, तो इस केस में हमारे पास ये Laplace transform यूज़ होगा. Okay, let me do some questions for you now. The first question we are doing, we need to find the following Laplace transforms. So how do you find Laplace transform of t square steric t e power t? So in this case we have two functions. One function is what, that is t square, whereas the other function is t e power t. So we first find f of s. So f of s, that is Laplace of t square, which will be 2 divided by s cube, whereas g of s, that will be Laplace of t e power t. Now we can use derivative rule, we can use shifting theorem as well. So Laplace transform of t is 1 over s square, and we multiplied with e power t. So using shifting theorem, s will be replaced with s minus 1. So that means this will become what? This will become 1 over s minus 1 square, right? So by using convolution theorem, this will be Laplace transform of t square multiplied by Laplace transform of t e power t. That is 2 by s cube multiplied by 1 over s minus 1 square. And we can combine them, 2 divided by s cube into s minus 1 square is the Laplace transform of this function. Okay, next one is Laplace transform of e power 2t and sine t. So again we could write that in the form Laplace of e power 2t multiplied by Laplace of sine t. Now what is Laplace of e power 2t? That is 1 divided by s minus 2 multiplied by sine t Laplace is 1 over s square plus 1. So altogether we have Laplace transform of e power 2t, and this one is s minus 2 into s square plus 1. Okay, that's the Laplace transform of e power 2t steric sine t. That's the condition. Okay, next one is what is Laplace transform of integral from 0 to t cos ta deta. So first you need to remember the rule here. The rule was Laplace transform of integral from 0 to t f of t dt deta, in fact, that was same as f of s divided by s. So in this case we have cos t as our f of t or f of ta, doesn't matter. Okay, so this is cos t, and you know that Laplace transform of cos t, that is s divided by s square plus 1. So this could be written as 1 over s into Laplace of cos t. So that give you 1 over s, and Laplace transform is s by s square plus 1. That would give you simply 1 over s square plus 1. There is another way as well. If you don't want to use any of these rules, so what you could do, you simply find integral of cos ta, which is sine ta, limits from 0 to t, that would give you sine t. And then you know Laplace transform of sine t is what? That is 1 over s square plus s square plus 1. तो उस तरह भी कर सकते हैं, इस तरह भी कर सकते हैं, ठीक है. ओके जी, Laplace transform of ta sin ta deta. अगेन इसमें हम इसी रूल को यूज़ करने लगे हैं, लेकिन यहाँ पर जो f of t हमारे पास आ रहा है या f of ta जो आ रहा है, that is ta into sin ta. So f of s will be what? F of s will be Laplace transform of ta s sin ta, which is basically same as minus d by ds of Laplace transform of sin ta. This is minus d by ds of 1 over s square plus 1, which could be simplified to get 2s divided by s square plus 1 whole square. ओके, डेरिवेटिव मैंने ले ली इसकी, इसके ऊपर लेके जाते हैं तो एस स्क्वायर प्लस 1 पावर -1 हो जाएगा. Now by using that integration rule, this is basically same as this is f of s divided by s, where f of s is found here, right? So f of s जो भी है उसको आपने क्या करना है, s के साथ डिवाइड करना है. So 1 over s into 2s divided by s square plus 1 whole square, in which these two s can be cancel each other. So we have 2 divided by s square plus 1 whole square is the Laplace transform of tau sine tau d tau integral from 0 to t. Okay, let's do some more question here. Laplace of cos t, in fact cos tau sine t minus tau. If you compare this with the integral from 0 to t f of tau and gt minus tau d tau, so that looks similar to convolution of cos t steric sine t. So this is basically same as Laplace transform of cos t steric sine t, which is basically will be Laplace transform of cos t multiplied by Laplace transform of sine t, whereas Laplace transform of cos t is s by s square plus 1, whereas Laplace transform of sine t will be s square plus, sorry, it's 1 divided by, my fault, 1 divided by s square plus 1. So altogether Laplace transform of this integral will be s divided by s square plus 1 whole square. So that is the Laplace transform of cos t, cos tau into sine t minus tau d tau integral from 0 to t. Okay, in this case, if you see, we are having t outside this integration. So in this, we need to apply the rule Laplace of t f of t, which is minus f dash s. तो यहाँ पे हम ये कह सकते हैं कि this is basically same as minus d by ds of Laplace transform integral from 0 to t sine tau d tau. It's minus d by ds. What about Laplace transform of this one? So Laplace transform of sine tau will be, by using this rule, क्या हो जाएगा, sine tau Laplace transform is 1 over s square plus 1, and then by using integration rule we will be getting s here. So that is 1 over s into s square plus 1, and then finding derivative of this, you can use it's minus d by ds of minus 1, sorry, it's plus 1 not minus. This is basically s cube plus s, and then you could find the derivative of this one. So we have in fact 3s square plus 1 divided by s cube plus s whole square, applying simple derivative of this one. So Laplace transform of t integral from 0 to t sine tau d tau, that will be 3s square plus 1 divided by s cube plus s whole square. Let's do some questions regarding inverse Laplace transform as well. So we have Laplace inverse of 1 over s into s minus a square. कीपिंग इन माइंड इसको हम डिफरेंट मेथड से कर सकते हैं. इसको हम इंटीग्रेशन के रूल से भी कर सकते हैं, इसको हम पार्शियल फ्रैक्शन से भी कर सकते हैं. हमारे पास रूल ये है कि लेप्लास इनवर्स ऑफ 1 over s into f of s, that is simply integral from 0 to t f of tau d tau, where f of tau is the Laplace inverse of this one. So the same thing is here. If we consider this one as our f of s, right, so f of s, that is equal to 1 over s minus a square, which is basically the Laplace transform of t e power a t. And then by using this rule, so this will become what? This will become integral from 0 to t tau e power a tau d tau. So I hope you can do that. Or we can use what? We can use convolution as well. Laplace of 1 over s into 1 over s minus a squared, which will be Laplace inverse of 1 over s into steric Laplace inverse of 1 over s minus a square. Still be getting what? This is 1 steric, again this is t e power t as we found here. And then by solving in convolution, we can get simply tau e power tau into 1 integration from there. So you can use either method, right? The same thing in this one as well. Just pause the video and try to solve this one. We are having s cube, but that means you have to integrate it 3 times. Or you can use just convolution, Laplace transform of 1 over s cube steric Laplace transform of 1 over s minus 1. So this is 2t, in fact sorry, t square by 2 steric e power t, where this can be then found as integral from 0 to t tau square by 2 into e power t minus tau d tau, using integration by parts to find this inverse transform. Laplace inverse of 1 over s into s minus 1, again this can be done by using either a partial fraction. You can do that by using integration. You can find this Laplace inverse by using convolution theorem as well. So that is Laplace inverse of 1 over s steric Laplace inverse of 1 over s minus 1. So this is what? Laplace inverse of 1 over s is 1 steric Laplace inverse of 1 over s minus 1 is e power t. Okay, so which can symbol then be found, or we can write that in this form as well. ये commutative है, so we can write this as a e power t steric 1. So this is by rule, it will be integral from 0 to t e power tau into 1 d tau, which could be found as well. Sorry, it's question number 6, not question number 5. It should be 6. Okay, so again the same thing here. This is Laplace inverse of 1 over s square steric Laplace inverse of 1 over s minus 1. Okay, so that is what? This is t and this is e power t. So we can again integrate that as from 0 to t tau e power t minus tau d tau. You can find the same Laplace inverse by using integration rule. You can because at the end you see we are back into integration, and we can use partial fraction as well, and so on. It's up to you. So thank you very much for being with me for that much time. So see you in next video. Please don't forget to subscribe my channel. And if you have any question or you want me to solve any question for you, so please, you may tell me book name exercise number and question number as well. So I'll just try to solve that for you. Thank you.